everyone. This is Asila AlHarmali, a PhD candidate in Information Systems at the College of Economics and Political Sciences in Sultan Qaboos University, Oman. I am delighted to present this paper on cyber risk assessment for cyber physical systems, which is a review of methodologies and recommendations for improved assessment effectiveness. And the agenda for this presentation, I am going to start with introduction to the research topic, followed by the research methods and the results and discussion. I am going to end with the recommendations for improved risk assessment effectiveness and any questions that you may have. So CBS is a paradigm in automation technology integrating computation and physical processes. Examples of physical domains in which CBS is deployed include environmental monitoring, water distribution, renewable energy, and smart grid, and many others. The integration of ICT systems, which is the information and communication technologies, creates new capabilities for the physical environment, such as live monitoring and control of physical processes with minimal human intervention. However, these computing technologies introduces new security vulnerabilities and exposes CBS physical resources to a range of cyber attack risks. If materialized, the consequences of cyber risks in CBS extends beyond the financial gain to encompass the physical world. These cyber risks can cause catastrophic impacts, such as manipulating or halting critical physical processes, consequently harming the public health and safety. Securing ICT in the context of CBS is more complex compared to standard IT systems. This complexity stems mostly from the nature of CBS applications, which are safety and mission critical with stringent requirement for high availability and real-time responsiveness. This real-time or uptime requirement makes the system sensitive to security updates, reboots, and many security controls countermeasures. Cyber risk assessment and cyber studies have been conducted on developing a CBS-specific security controls such as intrusion detection and prevention systems, security information and event management systems, and AI utilization. However, despite these contributions, cybersecurity breaches in CBS are on rise and with more sophistication and complexity. So technical security controls alone are not enough to address the given state of CBS security. Therefore, the CBS system should be prepared for inevitable cyber attacks through proactive risk management, which is a vital process for preventing cyber risks, reducing their impact or probability to a level deemed tolerable for the organization, or effectively handling them when they occur. Risk assessment is a core function in the risk management process, which identifies the potential cyber risks and evaluates their severity and likelihood. It has been said that the more effectively an organization can assess the cyber risks, the more rational, effective, and valuable its cybersecurity investments and approach will become. Although various cyber risk assessment approaches for CBS have been introduced in the existing work, it is not really well understood how effective they are, and this is the research problem in this paper. So, the main aim of this paper is reviewing 28 cyber risk assessment approaches for CBS published between 2014 and 2023 with three main objectives: identifying the methods researchers follow to evaluate their proposed cyber risk assessment methodologies, investigating the potential effectiveness of these methodologies, and identifying the gaps causing limited assessment effectiveness, and providing recommendations to overcome the most challenging limitations. So in the research methods, this study adopted a literature review to better understand the effectiveness of the existing cyber risk assessment approaches for CBS. A three-step search process was followed to search for scholarly contributions. The first step determined the research questions and defined the search keywords and the digital libraries to search in, resulting in a total of 1,329 publications. And in the second step, the abstract of each section the abstract of each paper gathered in the initial search was scrutinized based on inclusion and exclusion criteria, resulting in 328 papers meeting the inclusion criteria. And in the following step, some sections in the 328 papers were examined against the level of contribution criteria, resulting in 53 studies being filtered out, and the remaining, or the 275 papers left, were preferenced based on their contribution level. From this preferencing, 28 publications were selected for this review. So, this study primarily seeks to investigate the effectiveness of the existing cyber risk assessment approaches for CBS. Two questions are formulated to achieve this objective. The first one looks for answers on the methodologies or the methods the researchers followed to evaluate their approaches, the evaluation criteria, and the thoroughness of the evaluation process. In the second question, investigates the potential effectiveness of these approaches by looking for characteristics within each methodology that, based on best practices, lead to effective assessment. And this is the list of 28 studies which have been selected for review. Regarding the first research question, which was how were the reviewed cyber risk assessment approaches evaluated? 89 of these methodologies were demonstrated through case studies. And these case studies were informed by various or different sources of cyber threats, like the demonstration of cyber attack scenarios in a simulation or experimental testbed, or those case studies informed by the author's knowledge. While these case studies were informed by realistic sources of cyber threats, nonetheless, they do not reflect the actual complexity of a real-world CBS system. For example, the case studies drawn from experimental and simulated testbeds are narrowed to a single or few most representative scenarios, which is not keeping up with the constantly threat landscape. And the case studies developed from the author's knowledge might overlook the practical aspects of the CBS system and also susceptible to the author's subjective interpretations and heuristics. The remaining 11% of the risk assessment methodologies were applied to real-world settings. However, the CBS system in these demonstrations was accessed only once for the proactive risk assessment. It was not revisited for the feedback on the effectiveness of the risk assessment method after the identified risks materialize. However, for a rigorous evaluation, comparing the proactive risk assessment to the reactive assessment conducted after the identified risks materialize is required. Additionally, independent security experts or the system owners analysis is needed to evaluate and further validate the risk assessment methodologies instead of being judged only by the authors themselves. Multiple criteria determine effective risk assessment, such as validity and reliability, which are pivotal criteria directly influencing the decision maker confidence in the risk assessment results when making risk management decisions. However, compared to these criteria, none of the approaches in the reviewed methodologies was thoroughly evaluated. The evaluation in the reviewed studies predominantly focused on the applicability of their approaches by showcasing how they perform their intended functionalities. So given these limitations in how the studied cyber risk assessment methodologies were evaluated for effectiveness, we recommend demonstrating a cyber risk assessment approach in a real-world CBS system. This is to gain confidence in its applicability to a real-world setting. Equally important is engaging security experts and system owners in the evaluation process, because their feedback enables realistic evaluation that reflects the practical challenges of the system and intra cases, and also isolate biases. The effectiveness of the risk assessment methodology should be thoroughly evaluated across multiple criteria, especially the pivotal ones like validity and reliability. Regarding the second research question, which investigates the effectiveness or the potential effectiveness of the study's cyber risk assessment approaches in terms of validity and reliability. In the studies where these two criteria are mentioned, there is limited specification of the features in the risk assessment methodology that indicates valid and reliable risk assessment. However, what has been found is that the review study conducted by Eggers in 2021 considered the source of cyber threat data the risk assessment technique rely on to rate their reliability. The NIST guide for risk assessment mentioned the age of information for evaluating the validity. The NIST guide for risk assessment also said that the precision of the risk assessment is affected by the subjectivity of the risk assessors, the trustworthiness of the data drawn upon, and the interpretation of the risk assessment results. Shorten described the essence of the risk assessment methods in terms of the aim, risk factors, measurement, sources of data, and the tools support. Based on these views, further, it has been concluded by us that the risk assessment to be valid and reliable, it is required to meet these key requirements, but not limited to them. Like definition of the risk model, trustworthiness of cyber threat intelligence on which the risk assessment relies, to identify potential risks and to evaluate their severity and impact, the consistency of cyber threat intelligence interpretations, and the automation support. Regarding the first requirement for a valid, reliable, and thereby effective risk assessment, a definition of a risk model. A risk model in the risk assessment is a core function in the risk assessment methodology that describes the risk determination process. The risk model identifies accessible risk factors and their relationship in a formula or a matrix as inputs to determining the overall risk level and value. However, the risk model in the reviewed risk assessment methodologies reveal limitations that could impact the validity and reliability of the overall risk determination. For example, the impact and likelihood, which are the prevalent risk metrics or risk factors in the reviewed studies, were decomposed into non-inclusive characteristics to determine their values. For example, some approaches assess the impact of a potential cyber risk on either a cyber or a physical system layer, but not both. In some approaches, also, the likelihood of a potential cyber attack risk was interpreted as the likelihood of successfully exploiting a vulnerability. However, in the real world attack scenarios, the successful exploitation of a vulnerability does not always lead to successful attack or successful impact on the CBS system. Another gap is the determination of the overall risk based on only one risk factor, like the impact, the vulnerability, or the likelihood, which may lead to underestimating the cyber threat. Moreover, some approaches might overestimate the risks because of not considering the defender's countermeasures and their role in mitigating the system exposure to risks. Regarding the second requirement for validity and reliability is the trustworthiness of cyber threat intelligence, on which the risk assessment relies for identifying potential cyber risks and estimating their impact and severity. The sources of cyber threat intelligence on which the studied approaches relied possess limitations that could diminish the assessment capacity to assess the potential cyber risks correctly. For example, the cyber threat intelligence information published in public security databases or governmental security reports does not reflect the organization's unique experience and can become outdated due to the evolving threat landscape, which may lead to inability to correctly represent the risks to which the organization is exposed. Also, given that the underreporting of OT incidents and the lack of scientifically verified data On cyber-physical attacks, this source is not reliable. A demonstration of cyber attacks in a simulation or experimental testbed does not also reflect the actual complexity of a CBS system and the risks to which it is exposed. And the threat event parameters, it is challenging for the threat event parameters to keep up with the constantly changing threat landscape. In case of insufficient knowledge about specific threat characteristics, the authors either omitted them in their attack scenarios or relied on assumptions. So the scenario-based approach is further narrowed when the threat was interpreted into a single or few most representative attack scenarios. Next, the past cyber attacks experienced by a real-world CBS system cannot correctly estimate the impact and likelihood of a potential cyber risk because the factors that led to cyber attack in the past has been changing. The historical cyber attack approach also lacks real-time learning of the threat landscape. The assessment based on querying security experts, system owners, or others or other analysts is susceptible to biases and misleading heuristics. And the third requirement for effective risk assessment is the consistency of cyber threat intelligence interpretations. Across different assessors, there should be consistency of the interpretations across different assessors. The inconsistent interpretation normally arises from the individual assessor's bias, where their beliefs influence how they assign a meaning to a specific cyber threat information. The ambiguity in the cyber threat information is also another source of inconsistency, where different risk analysts comes to a different conclusion about a specific cyber threat information. Moreover, when the cyber threat intelligence source provides incomplete information about a specific threat, the assessors or the human assessors make their own assumptions to fill these gaps, which may lead to varied interpretations and opinions. What has been noticed is that the reviewed approaches lacked methods and techniques for structuring how to interpret lessons about the potential cyber risks, leaving a room for varied interpretations. The fourth requirement for valid, reliable, and thereby effective risk assessment is automation support. Among the reviewed risk assessment methodologies, 75% of them lack software support, relying completely on manual efforts of the risk assessors. In the remaining 7 approaches, the authors developed software tools or created Python or MATLAB scripts. However, the intelligence of these tools and scripts provided by these tools and scripts is limited because of the following. Either they are not complementing the assessor's knowledge with real-time learning from the publicly available threat intelligence sources and the cybersecurity incidents the organization undergoes, or they are not automating the modeling and simulation of the threat scenarios based on what they learn in the first step. So overall, the maturity level of these technical solutions is not high because of not facilitating a risk assessment process from preparation for the risk assessment to conducting the assessment, communicating its results, and maintaining it over time. With this lack of high-level automation support, human assessors cannot effectively analyze the relevant cyber threat scenarios in real time. So in light of the preceding analysis in the second research question, the answer is that the reviewed cyber risk assessment methodologies reveal limited effectiveness in assessing cyber risks. With regards to the recommendation, The more challenging factors impacting the risk assessment effectiveness, which has not been adequately discussed and addressed in the existing literature, are these two: the trustworthiness of cyber threat intelligence information sources on which the risk assessment relies for identifying and evaluating the potential risks, and the consistency in the way human assessors interpret this cyber threat intelligence information. So, as recommendations, first, real-time learning from cybersecurity incidents or real-time learning from cybersecurity incidents the organization undergoes can complement the assessor's knowledge with up-to-date information about cyber risks, the information which represent the organization's unique experience and the complexities of a real-world CBS system, thereby enhancing the trustworthiness of cyber threat information sources on which the risk assessment relies. Automation support is also crucial for real-time learning from the cybersecurity incidents and the other sources of cyber threat intelligence. A machine learning-based software tool is proposed to enable real-time learning from the cybersecurity incident as it occurs to avoid erosion of knowledge, and then update the risk assessment process. Machine learning can reduce manual efforts, thereby better structuring the acquisition, retainment, dissemination, and application of the knowledge about potential cyber risks. Machine learning capabilities can contribute to minimizing human errors and thereby inconsistencies in the cyber threat intelligence interpretation, which is the second challenge. So, to summarize, the findings of this study revealed that the effectiveness of the examined risk assessment approaches was predominantly evaluated in terms of applicability, but not other pivotal criteria like validity and reliability. The existing cyber risk assessment methodologies have been found to fall short in conforming to the assessment effectiveness requirement, with multiple factors leading to this shortcoming, like definition of the risk model, trustworthiness of cyber threat intelligence, consistent cyber threat intelligence interpretations, and automation support. In terms of recommendation, a machine learning-based real-time learning from cybersecurity incidents can contribute to overcoming the gaps that limit the risk assessment effectiveness, or the most challenging gaps that affect the risk assessment effectiveness, which are the untrustworthiness of cyber threat intelligence and the inconsistent interpretation of this cyber threat intelligence information. For future research, it is required to investigate the contribution of the given recommendation in addressing the most challenging gaps impacting the assessment effectiveness. Thank you for your listening, and you have